Okay, Assalamualaikum warahmatullahi wabarakatuh, and very good afternoon to all of you. So, can you hear my voice?
Yes, Doctor.
Yes,
Okay.
Doctor.
Yes, sir.
Okay. So I hope you are in good conditions, sihat walafiat So, okay. So this is I think the last part of the single phase transformer. Okay. Actually, in the transformer, there are three parts. The first one is the transformer testing using the no load test and also the short circuit test to obtain the parameters of the transformers. And the second main part is the voltage regulation of the transformers. Okay. So voltage regulation is very important performance analysis. It's very, sorry, not analysis, performance parameters. So the good transformer have what we call a good voltage regulation, meaning that there is a slight difference between no load voltage and full load voltage at the output side, meaning that the losses, the voltage drop across inside the transformer is very minimum. Okay, so if you have a voltage regulation that is very small, so your transformer is very good. Okay, that is the indication. Okay, so voltage regulation is the second main part in the transformer. And the third parameters, the third part in the single phase transformer is what we call the efficiency of the transformer. Okay, and okay, so the transformer, that is the three main part. Next week, where actually the pre-recorded video I will share with you after this, we will go just briefly, okay, briefly on the last part, which is the auto transformer and also the three-phase transformer. Okay, so that one is just a brief. Okay, that one I think will not be assessed in your final exam or your test. Okay, because that one just a very brief introduction, very brief informations about the auto transformers and also the three-phase transformers. Okay, but I just want to concentrate on the single-phase transformer. So actually, the three-phase transformer that we will discuss after this, using the pre-recorded video, is actually just what you call three-phase representation of the single phase. Okay, so if you understand the single phase, then I think no problem in understanding the three-phase transformer, because actually the three-phase transformer, the analysis is actually we represent into a single phase, because we assume that the three-phase transformer is balanced load, a balanced system. So the analysis is always referring to the single phase equivalent circuit. Okay. So, okay, so right now let's look at the example of the voltage regulation, example 5, okay, from the notes. Okay. Okay, based on example 3, calculate the voltage regulation and the secondary terminal voltage for full load having a power factors of 0.8 lagging and 0.8 leading. Okay, so I have do the solution, but only for the lagging. So I hope after this, you can try to do the same example here, but when the power factor is leading. Okay, so first of all, what we need to do is to have the equivalent circuits of the transformers. Okay, so based on example 3, so it has give you all the information here, which is A is equals to, which is N1 over N2, right? The ratio of the number of turn, where the number of turn is 400 at the primary side and 80. So meaning that this one is 5, meaning your A is 5. Okay, so your A is 5. And then it also have give you R1 and also R2. Okay, So your R1 is 0.3 and your R2, which is your secondary, is actually 0.01. And also it also gives you X1, which is 1.1 and X2 0.035 ohm. Okay, this one is J, okay? J, all is J. So what you need to do is to have the equivalent circuit. Okay, so right now usually we always refer all the parameters at the primary side. So as can be seen here, we have represent the R equivalent, which is R1, and your R2 is actually transferred into the primary side. So this is the equation. Okay, so R1 is the primary, and this is A square R2 prime is actually the resistor of the secondary when we what you call transform or transfer into the primary side. Okay, and this is your XE1. Okay, which is we have calculated earlier, which is will give you the value of 0.55 and 1.975. So this is actually Z. Okay, so Z is 2.05, should be an angle here, which is represented by 0.55 plus J 1.975. Okay, so if you don't remember, so you can try to use these values. You should get the value of the impedance. Okay, so that is the first step. What you need to do is actually to obtain the parameters of the transformer. So right now we have already calculated the R equivalent and X equivalent uh, transfer to the to the primary side. Okay, RE1 and also XE2. Okay, okay, understand? So I hope you can follow me until this part. This is very important part. Okay. Okay. Next is to use the voltage regulation equation. So based on the notes that I have already shared with you, so this is the when you have your power factor lagging, okay, so you need to use positive. Okay, so this is I R1. So this is actually just a magnitude, okay? All are magnitude only. Cos of the theta, this is your angle, okay, power factor angles. And depends on the power factor. So if your power factor is lagging, choose plus. And if your power factor is leading, you need to change this into negative. Okay, so this one is lagging. So plus I1 X1 sine theta. So there is no J here. Okay, so please exclude the imaginary J. Okay, so this is only the magnitude. Okay, multiply with the sine theta and over your V no load actually. Okay, V no load. Or in the notes is actually the V1. Okay. So this is actually the equivalent circuit where your V1 is voltage supply. Okay, sorry, this one from example 3. So 2200 volt. Okay, and V2 prime. Okay, because this one V2 prime is actually the voltage secondary that we have transferred into the primary side. So that's why we have V2 prime. Okay. Okay, I think this one is not R prime. This is R2. Okay, so please uh, correct this. So this is R2. Okay. What is the difference of R2 and R2 prime? Okay, I just do the correction. Okay, so R2. This one is actually R2. Okay, so the whole part, this one is actually R2 prime. Okay. This one also, the whole one here is actually x2 prime. Okay, Oscar, can you get it? Okay, please do the correction. Okay, so this is not R2 prime, this is R2. Okay, so A square R2 is your R2 prime. Okay, so the supply voltage is 2200 volt RMS. Okay, so right now all the voltage is actually RMS. If not given, so you can actually ask, okay, whether it is RMS or Vmax. But usually this one for transform we always refer to RMS. Okay. Okay. Okay, so right now, what we need to do is to obtain what is the current. So right now we have already get the R1 and X1, which is your R equivalent 1 and X equivalent 1. Okay, the parameters that we still need is what is the value of your current and your angle. That one is unknown. Okay, sorry. This one is actually known, which is 0.8, right? Lagging. The theta. So from that you can get the theta. So actually from the theta, okay, your theta is actually cos inverse of 0.8, which is I think we have calculated it, which is what is the values? 36.86. Okay, that is your theta. Okay, so your theta is obtained based on the power factor which is given here. Okay. So the current right now. So what is the current? The current that we always refer is actually the the full load current. Okay, the full load current. What is the current that flow when the load connected to the transformer is its rated values? Okay, so the rating of the transformer is 100 kVA. Okay, please be noted that this one is your rated uh, parameters. Okay, so since this is a big transformer, so we are usually rating the transformer in VA. If the transformer is small transformer, we are usually use kilowatt as the rating. Okay, but for the big transformer, we are using the apparent power rating VA. Okay, so this is the rating. So to get the rated current, so you need to use S is equal to VI. So this is your V rated, and this one R current is your I rated. So this one is your rated. So S rated is equal to V rated multiply with I rated, which is also we call full load. Okay. So right now your S rated is 100 kVA. Okay. Over your V rated is actually 2200. So you will obtain the values, okay, only the magnitude, 45.45 amperes. Okay, then you can use that information to obtain the voltage regulation. So 45, just substitute the current, the resistor values, the cos theta 0.8 plus the current, the X. Okay, as you can see, the X is only the magnitude. Please exclude J. Okay, multiply with the sine theta, 36.86 degrees over your V1. Okay, so this is your V1, V input. So from that, you will obtain that the voltage regulation is around 0.033. Okay, so which is which is 3.3%, which is not very good actually. This for the transformer that has a very good voltage regulation, usually around maybe 1% or less than that. Okay, because we want that the transformer have a very minimum voltage drop. Okay, so if the voltage regulation is big, meaning that there are a lot of voltage drop inside the transformer, so losses. Okay, so we don't want that. Meaning that the materials they use inside the transformer, the inductance, okay, is actually high losses inductance and high losses resistance. The material use is not good. Okay, usually for a good material use, they will have a very minimum voltage drop. Okay, so actually voltage drop is related to the losses. Okay, okay. So next is actually what is the voltage? What is the voltage at the secondary side? Okay, the second equation, the second questions. What is the secondary terminal voltage? So right now we have already obtained the regulations. Okay, and then this is actually the original equation of the voltage regulation. You need to remember this. Okay, the equation V no load over V full load over V no load. Okay, so V no load is actually, this one is actually referring to uh, the secondary side. Okay, so we have this one which is a 0.033. Okay, and then we know that when there is no load here, when this load is disconnected, so what is the V2 prime here? What is your V2 prime when you disconnect the load, meaning that V no load? Here. What is the V no load appears here when you use a voltmeter here? When you disconnect the load, so the voltage that you measure here is your V no load. Can someone answer my question? What is the value of V no load? Yes, actually equals to your V1 because when this is no load, your current here is zero, right? So your current is zero, meaning that there is no voltage drop across here. Okay, there is no voltage drop, meaning that your V no load is equals to V1, which is 2200 volt. Okay, so that's why that is what's the meaning of V no load. When you have load disconnected, what is the voltage you measured from the output terminal? Okay, so 2200 volt. So you substitute the V no load, which is with the 2200 volts. Okay, so from there, so you substitute this. This one is V 2200. This one is also 2200. And then you have the voltage regulation. Then you can obtain your V full load. Okay. So the V full load is actually the voltage to prime. Okay. When the rated load is connected. So as you can see, the V full load is 2120 volt, which is less than the V no load. Okay, V no load is 2200. But when you connect with a load, the voltage drop a little bit. Okay, from 2200 into 2120 volt, which is logic because you have a voltage drop, right? We have the internal resistance, you have the you have the reactance. So definitely they will have a voltage drop. But the value of the voltage drop is depends on the resistance, the material used. So if the material is very expensive material, is a very good material, so usually the internal resistance is very, very small, and the reactance is also very, very small, meaning that your voltage regulation is very good. So you should, for a voltage regulation that very good, meaning that your voltage output here may be around 2180. So very, very near to the V no load. Okay, that is the what we mean by voltage regulation. Okay. So, but still we didn't finish yet. This one is actually the V2 prime. Okay. The V2 prime here, right now. the value that we obtain is 1000 to 120 volt is actually V2 prime. The voltage secondary that we have referred to the primary side. So the question is actually what is the V secondary? So what we need to do is actually to transform back into its original values. So this is actually the relationship. Okay, you need to always remember this one. Okay, so V2 prime is the voltage secondary that we have transferred to the primary. So the original is V2 here. So from that, you can use this equation. So you can get 425 volts. Okay, so this is actually a step down voltage, a step down transformer. Okay, because it stepped down from it didn't give you the value, but it's actually 400 turns into 80 turns. Okay, secondary. Any questions? I hope you can this one, because this one will be inside your final exam. Okay, the transformer. It will be not inside your test too. Okay. Any question regarding this? Okay. Test 2. Test 2 will be cover that topic that we didn't yet covered, which is the transmission line. But that one is a very easy topic lah. Okay, that one, the question I will design the question actually for the test 2. Okay, so very easy that topic. So we will that topic will be next week. Okay, we start that next week. And then another one is the second question is also about the power generation. I think power generation. Also, we didn't cover yet. I think in my first class, I have already mentioned about the complexity of this syllabus, of this course syllabus. Is very complicated and actually a very large syllabus that need to be covered. So that's why for the auto transformer and the three-phase transformer, we just go brief. Okay, I think we just need you just watch the pre-recorded videos. I think that is enough. Yes, for the assignment 1, only one representative. Okay, yes, one group. Okay, so meaning that only group leader will send. Okay, not everyone. Okay, because because there is a one question here for assignment 1, only one representative sent to e-learning. Yes. Okay. And that assignment actually not very, I will not penalize the student because that one is quite tricky actually. The assignment is quite tricky, and then you need to learn by yourself, okay, on the tariff. Actually, we will introduce you about the tariff, but that one is actually at the last part of the chapters of the syllabus. So meaning that you need to self study first on the tariff. Okay, so you just do the best, and then do not worry that I will not penalize largely on the assignment, because we have another assignment which is regarding on the renewable energy generation. Okay, capacitor can be connected delta or Y. Yes, you can either connected in Y or delta. And yes, there is a difference in terms of the values of the capacitors. Okay. So in the design, as you as the engineer, when you involve in the design, there will be no right or wrong. Okay, the design meaning that you need to design the system to be it depends on the objective. Okay, it depends on the objective you need, but the objective, you achieve that objective by following the guideline. Okay, the standard guideline. So if you following the guideline, your answer or your final decision will be always good. Okay, they will be always good, and then there will be no what you call problems in terms of the engineering ethics, engineering mathematics, and so on. So usually when you follow the guideline, you will achieve something. Okay, maybe it's not optimized. Okay, so it depends on the objective. So the design is actually there is no right or wrong. Okay. Okay, why in real life, the VAN, VBN, and VCN is not exactly the same? Okay, so for three-phase system, oops, why my battery is running? Okay, my battery is running low. I need to shut off my laptop first, and then we will continue again. Okay, so I need to restart again. I don't know, maybe my battery's got a problem here. Okay, meet you again after this. Okay.